Hello guys, welcome to my blog. This is the first video I'm making in a while. The purpose of this video is trying to show you some conclusions that I have arrived after I make a few tests in the Fanuc robot. So this time I will be analyzing the data from the circular test. I can show you what was the circular test. So in X we have the timestamp, which I have divided by 1 million, as you can see, because the time is given in microseconds and I want to analyze it in seconds. In the y-axis, I believe we have the y axis of the robot, and in the z-axis we have the z-axis of the robot, I think, and this should show us exactly. So just to be a little more as you can see, the robot made 1, 2, 3 circles, and this will be the data that I will be analyzing. So for starters, what I will do is analyze the raw data that comes from the robot, that comes from the sensors, I'm sorry. So yeah, basically what we need to understand is that this black line represents the data that I obtained from the Fanuc robot. This is the correct data, so to say, and these blue lines will represent what I have been what I've taken from the sensors. So in this case, I've got the accelerometers. As you can see in X, we did not made any kind of movement. If we look closer, we might find that there are small variations. So we're starting to see, but it's not really that much of a variation. And in Y and Z we can see the sino and cosino because we are making circles. Okay, so the first thing I will be analyzing, as I said, is the accelerometers. Basically the accelerometers measure forces. As we can see, we are sensing a force in Z, in Z-axis of 255, more or less. This force represents the force of the gravity. In Y we have no forces at all, are almost zero. The important thing that we need to remind here is that 255 is equivalent to 1 g, or 9.8 meters per square second, I guess. And as we can see, there are no obvious conclusions that we can get from this data. As you can see, the data is variating, there is a little error. However, it does not behave how I was expecting. The first time around, I was expecting that even though there will be this error, the acceleration will do something like this, and it is not doing this. And the same happens in Z. So the first conclusion, I guess, is that we cannot take conclusions from the accelerometers. The next thing I will analyze is the gyroscopes. We can see in the gyroscopes that there are 3 major changes. I don't know why they happened. I believe that this might be some, I don't know, maybe the robot had some major variation in the position or something that maybe it's rotated a little bit, which gave us this result. But then again, we can see that as far as epsilon and z, the values are very close to zero, okay, and they do not follow the main line as that would be expected. And finally, in the magnetometers, we can see that even though it does not seem like it, the magnetometers are following kind of the same curve. If you see, goes up, goes down, goes up, goes down, and goes down, goes up, goes down, goes up. However, I believe that the magnetometers are influenced by, what is this? We can see that yeah, the magnetometers probably are influenced by the electric current that is passing through the robot. So it is kind of explained that if the sensor are closer or further from the robot, that the magnetic field varies according to that distance. So even though I can take some conclusions from this applying to the robot, I cannot do that apply to the humanoid because as the sensors will be always in the same relative position to the servo motors, the only thing that will influence the magnetic field is the current that the motors are getting, so we cannot take any obvious conclusions. So far I saw that I cannot take any direct conclusions from the raw data. Now I will try to... So, Telmo Rafeiro, who has worked with the sensors, has developed a node, a Rosbach node, that converts the raw data into filtered data. He gives us three fields: the linear acceleration, the angular velocity, and the angular position. What I will try to investigate is if these things that he give us in fact any information. But as we can see in the linear acceleration, the conclusions are more or less the same that we got from the accelerometers, because the values of the acceleration does not change at all. However, if we think this, what was to be expected is that in this linear or more or less linear segments, the acceleration would be zero, but then here it would be starting to become negative, and then starts to increment in the negative position. Then it goes to zero, not zero, constant, which would be a constant acceleration, and then starts to increase, then constant again, so far. So we would probably get, or we should get, something that will look like this also. But we did not, so I don't know how I can take this how I can take conclusions from this. Maybe it is not possible. So I believe the first real conclusion that I got is that accelerometers are not possible to get, are not enough to take some information, so to speak, of the sensor's position. And unfortunately, I have the same thing from the angular velocity. I cannot take any real conclusion, nor from the angular position. If we check the angular position, we know that the angular position is more or less the same. This is actually accurate because when I did the test, the sensors were always on the same relative position, according to gravity at least. So yeah, I don't think we can take much conclusions from analyzing the data that is coming from the sensors, at least for what we are trying to analyze. So I believe that the best thing to do from now on is try to get some other information that we are not getting right now. I will try to explain in the next video what I have developed in order for me to get some actual important data from the sensors. So yeah, thank you for watching, and see you next time.